In this lesson, we're going to finish adding to what I'm going to call your trigonometric toolkit, in that we're going to add some tools that allow you to solve for missing angles and sides for right angle triangles specifically, adding on to the first one you learned about called tangent. So, in this triangle, again right angle, I'm going to allow this to be an angle of interest, and we'll call it theta for short, and it's spelled Theta when we talk about this unknown that we use for angles. Okay. Now, we learned in the last lesson that the tangent ratio of this angle is equal to the side that is opposite it. So I'll put this one here, opposite, divided by the adjacent. And that we can all relate to this in everyday life as being the slope of a ramp that starts on the floor and goes up to some height, knowing it is the rise over run ratio, right, of a particular angle. Well, what if you don't know one of these two things and you're trying to solve for a third one? Is there maybe a way that we could get the hypotenuse involved? And the answer is absolutely. Before I do that, though, again, let's remember the hypotenuse is always, always, always opposite the 90-degree angle in the triangle. It's always the longest of the three sides. So I want to introduce to you two more trigonometric ratios we can use. The sine of an angle, or Sin for short, is equal to the opposite of that particular angle. So it starts off the same as tangent, but instead of being divided by the adjacent, it gets divided by the hypotenuse. And there's one other combination of sides that we can use as well. If you look at the combinations we've used, you can figure that it maybe involves adjacent and hypotenuse as well. And you'd be right. The cosine of an angle is equal to the ratio of its adjacent to its hypotenuse. So someone clever came up with a little acronym to help us remember all three of these trigonometric ratios. And this little acronym begins with sine actually first. It's called SO, CA, TOA. And this is where, if we were in class, I would break into the Alleluia chorus to help you remember SOHCAHTOA. But SOHCAHTOA is a short form way. You may see it written in other places as this. I prefer to do it this way because then you can actually kind of see the ratio of which side goes with which side for sine, cosine, and tangent. The only thing that's not included in this little acronym is that when we have this capital S, C, and T, it stands for sine, cosine, and tangent of an angle. So it implies that the angle theta there is the unknown when you see these three letters put together. So SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. All right, how does SOHCAHTOA work for a particular triangle? Well, let's explore how all three of them are related within a given triangle. So let's begin with the first one that you see in your note. First triangle looks something like this. It's been rotated just so we don't get used to the 90-degree angle always being on the bottom right. That's good for us. We see that this side length is 24. This one's 26, and this one's 10. And we would like to know the size of this particular angle right here. And example 1 says, let's find the primary trig ratios for each angle, and then we'll find out what the measure of that angle is. So this is good practice for us in identifying the opposite, adjacent, and hypotenuse sides of any given triangle. The easiest one to always identify, of course, is the hypotenuse, because it has to be opposite the right angle. I'm going to put an H there for that one. Okay, then let's look at the opposite, because that's the one that's, I think, the second easiest. It is always across from the angle of interest, or the angle that you have designated that you want to know more about. So that would make the 10 here the opposite side. Okay, it's not a 0, it's an 8, it's an O. And then that would mean the remaining side, this one here, between the right angle and the angle of interest, would be called adjacent for the specific angle. So let's write down all three trig ratios, remembering SO, SOHCAHTOA in the process. And maybe you want to write that at the top of your page while you're learning what these different ratios stand for. So if we were to start with the sine of this angle, theta, we know that sine is equal to opposite over hypotenuse. So in this case, the sine ratio for angle theta would be opposite, which is 10, divided by hypotenuse, which is 26. And we can punch that into our calculator, and let's write it to 4 decimal places as the question suggests we should. And we get an answer of 0.3846. I notice that after my 6 it's a 1, so I'm going to leave it as a 6. And I notice that this is not an exact answer. In fact, these digits repeat over and over again, so we're going to put approximately equal to like that. All right, let's do a similar thing and just write out the primary trig ratio using the cosine relationship. So the cosine, according to SOHCAHTOA, is adjacent over hypotenuse. So if we look at our diagram, the adjacent side for this angle theta is 24, and the hypotenuse is still 26 because its designation never changes. And so if we punch that into our calculator, we end up with an answer of 0.923, and I'm going to round that to a 1. And I hope you're following along with your calculator as I'm doing this, because watching it and doing it are two different things. And these are brand new buttons on your calculator. I want you to become very, very comfortable with them. Last, let's develop the tangent ratio. It was the first one we learned about in this group of 3. Tangent is equal to opposite over adjacent. So again, with respect to that angle, opposite has a value of 10 and adjacent has a value of 24. And when we punch that into our calculator, we get a value of approximately 0.416. Then I've got a whole bunch of 6's repeating, so I'm going to write a 7 here as the 4th decimal place. Okay? So when it asks us for the primary trig geometric ratios, it's looking for this value here. You can leave it as a fraction or you can express it as a decimal. Okay? These are the ratios in both forms. Okay? So finding the ratio is great, but the best part of it all then is, as we see in part B, is actually figuring out what theta is. Okay? So what I'd like you to do is go back and punch in 10 over 26 in your calculator so that you have this decimal handy. Let's do it for sine first. We know that sine theta is 0.3846 and some change, right? And just like we did in the tangent lesson, I would really like to figure out what the value of theta is. But this sine function is in the way. So guess what? We can get rid of it by doing its opposite operation, which is the inverse sine. And it works exactly the same way that inverse tangent did in our previous lesson. So even though on paper I have written here 0.3846, I actually want to keep all the digits of this fraction as a decimal in my calculator when I do the calculation to give the best accurate answer that I can. So again, remember from last lesson, when we use inverse sine or inverse tan or inverse cosine, we always write it at the beginning of both sides of the equation, and we then show after it the value we're taking the inverse sine value of. So if we do that, and I'll walk you through, I have 10 divided by 26. Here it is as a decimal. And I want to take the inverse sine of that value. So again, here's my sine button. If I want to use inverse sine, I have to use shift first. And then I can recall the answer that I just had in memory, which was this 10 divided by 36 value. And it says that the angle that's right here in this triangle should be about 22, and I'm going to go to 1 decimal place, 22.6 degrees. Okay. Now, it should be interesting to see if this holds true no matter which of these trigonometric ratios we use. Do we get the same answer regardless of which one? Well, let's find out. Let's do a similar calculation of theta using the cosine ratio of 24 over 26. So again, I'd like you to punch in 24 divided by 26 in your calculator and have all those decimals handy in your calculator to give you the best value of theta. In a similar fashion, if I want to solve for theta, I need to get rid of this cosine piece using its inverse operation, or its opposite operation, which is inverse cosine. And whatever I do to one side of the equation, I have to do to the other side as well. And again, remember, inverse cosine gets written first, followed by the value you're taking the inverse cosine of. So I'm going to go back and I'm going to put 24 divided by 26 in my calculator, get it as a decimal. There it is. Don't have to have it in decimal to continue, but most of you prefer that. And then again, if I want to use inverse cosine, mine's right here off on my cosine button. I have to push shift first, inverse cosine of the answer I just had. I don't have to close the bracket, but I will. Equals, hey, 22.6 degrees. Well, isn't that interesting? That's exactly the same as the angle measurement that we got using the sine relationship. Well, they say 3 is a charm. Let's see if the same thing holds true if we do the tangent relationship. So tan theta from above is 10 over 24. I'll choose to write it here as a decimal. But again, before you do any further calculations with it, make sure that you have it as a decimal with all of its digits in your calculator. I'm going to take the inverse tangent of both sides so that I'm solving for theta. Writing it as such. Punching it into your calculator. Again, let's go back up. 10 over 24 is the best value. There it is. I'll leave it in fraction form this time just to show you it doesn't have to stay as a decimal. And I'm going to use the inverse tan button. So shift inverse tan of my answer. Hey, 22.6 degrees. So isn't it cool that all three of these trig ratios support each other and give us the same value? That's really powerful because it means we can solve a whole lot of stuff. So tell you what, let's solve a whole lot of stuff. Let's try another triangle together. The second one that's in example number 1. Okay, so same exercise. Let's see if you can predict where I'm going with this each time. Maybe even pause the video, predict, and then unpause it to see if you're right. See if you can start to make the thinking yours. Right? Here's theta. Part A says come up with the trig ratios. That means the decimal value or the fraction values of relating the two sides for each identity. Okay. Step 1 is to identify where's the hypotenuse, where's the opposite, where's the adjacent with respect to this angle theta. Pause the video, make a prediction, and then unpause to see if you get it. So how'd you do? Did you guess that this one was the hypotenuse opposite the right angle, and that this one's the opposite because it's opposite my designated angle, and therefore this must be adjacent? I hope so. I hope you got it, because that's the first step in working with trigonometry always, is to identify your sides. Let's now come up with the trig identity ratios for each of them. Why don't you pause the video, see if you can do it, and then unpause and see if you got it right.